100%. You're probably wondering, 100% of what? This is the percentage of the water in the U.S. that is contaminated by at least some sort of pesticide. Good evening. My name is Joise Jacobson.
And my name is Rutendo Ghuza, and today we're sharing with you our assessment of species sensitivity amongst Daphnia to fungicides. So for some background, pesticides are any type of substance that mitigates some type of pest. They're recognized as highly beneficial for protecting crops and have a very widespread use, and this combined with their water solubility accounts for their prevalence in the water. Some types of pesticides are herbicides, rodenticides, and fungicides.
But fungicides are the most common kind of pesticide that is detected on our water surface. The main cause of this is from all sorts of things, from runoff from agricultural fields, from lawns, from streets. They also come from seeping into our groundwater through soil, through spills, through space, in so many other different ways. Not only is this concerning for the marine life, but it's concerning for our lives. 385 million cases of pesticide poisoning happen each year, and of those cases, 11,000 people die. They are also known to cause neurological diseases like Parkinson's disease, and also they can cause many different kinds of cancer.
A huge player in monitoring this occurrence is the Environmental Protection Agency, or the EPA as we'll refer to them. They aim to protect people and the environment from significant health risks. They sponsor and conduct research and overall develop and enforce environmental regulation. Specifically, in regards to pesticides, EPA is one of the biggest hurdles that pesticide manufacturers have to get over in order to get their pesticide registered, which is required for public usage. One of the things in the process of approval that the EPA does is run toxicity tests utilizing animals like marine invertebrates to get estimates for how the pesticide will infect the environment. And the results from these tests are usually listed in the Pesticides Material and Safety Data Sheet, or MSDS sheet.
So, meet Daphnia. This is one of the types of the invertebrates that the EPA utilizes in their toxicology studies. Daphnia are often referred to as water fleas and are part of a genus within the Cladocara family known as Daphnidae. They are considered a keystone species in our aquatic ecosystem. They are a highly essential part of our food chain for freshwater fish like sockeye salmon, minnows, sticklebacks. They also, despite their role in the food chain, help maintain our water quality by having a large appetite for algae. Finally, they are also known as indicator species used for water toxicity testing done by the EPA. So this is because they are highly sensitive to a wide range of aquatic contaminants. So as you can see on the screen, here are only some of the 500 different Daphnia species. There are two main categories of Daphnia. There's the wild type, and then there's the lab-raised. The lab-raised, or the EPA, are used with the ones for running ecological toxicity tests. In comparison to the total number of Daphnia species, 500, they only use about 6 in their studies. So this concerning number is what we're going to go into a little bit later. And then the wild type Daphnia is just the wild type.
So some prior research that guided our assessment firstly was McIntyre, who in 2015 with a group of researchers at Washington State University assessed the efficacy of soil bioretention in protecting juvenile salmon and their prey from the toxic impacts of pesticide-infected urban stormwater. They found that in using surrogate species to do environmental assessments, this can cause misleading results due to differences in species life histories. This finding introduces the commonality of inconsistencies due to underrepresentation. Next, our amazing mentor, Dr. Dresnick, with a group of researchers at Washington State University, ran a comparative studies of 2 cladoclarian species, and the data from this study reassured the fact that all Daphnia are not the same and therefore should not be compared to just a few representatives.
So, with the guidance of these previous experiments, our gap, or what led to our research, is that there's actually limited data on the difference between lab-raised and wild-type species sensitivities to fungicides, making us wonder if the EPA guidelines are truly applicable and protective to all species within this genus. So, this limited amount of data is what led to our problem statement. So, as we said before, the difference of sensitivity between the lab-raised and the wild-type to fungicides is unexplored. So our objective with this problem is through toxicity testing, we're going to statistically compare the different species sensitivity to a fungicide of our choosing. Then we hypothesize that the fungicide will have a negative effect on the wild-type species at a higher rate than it will for our lab-raised or our EPA species. So here you can see is the role of Rutendo and I versus our mentor, Dr. Dresnick. On the left is what we did, and on the right is what she helped us with. So we conducted our research alongside her at the WSU Puyallup Extension Center, and without her, we would not have been able to do this project because we had no idea what we were doing. So thank you, Dr. Dresnick. Okay, now we're moving on to our timeline. So highlighted on the left, this is the first half. So in the first couple of weeks, this is when we actually had to design our study. So this came with identifying the actual elements within it. We chose our fungicide, we ordered the Daphnia for the lab raised, and then for the wild type, Rutendo and Dr. Dresnick went out to local freshwater places in Puyallup to collect the wild ones. After this is when we actually started our daily maintenance of them. So this included feeding them 3 times a week, checking them daily, removing the broods, removing the neonates, so this means that we got rid of the offspring, and then we only had the adults in the cup for the 2nd through the 6th brood. So all of this was done within the EPA's guidelines.
The fungicide we chose for our assessment was Rutendo Gold, which contains the active fungicide mefenoxam. We chose this fungicide because during a Washington pesticide monitoring test assessment of 289 samples across 16 sites in Washington, mefenoxam was noted as one of the most common ones and also seen in the highest concentration. Unlike the EPA did, they tested the pure mefenoxam when creating their MSDS sheet, seen on the right, but instead we used the active product formulation rather than the pure chemical as it's sold and applied in real-world scenarios as seen on the left, because we wanted more environmentally accurate results. The 2 species of Daphnia that we used was the Daphnia dubia, which we referred to as our lab-raised, and this is one of the few EPA standard species. We use this because in toxicology studies, they have consistent breeding and are easily manipulated in controlled conditions. Next, we use the Scapholobarius micronata, which we refer to as our wild type. They're found in natural freshwater environments and offer insight into real-world responses, and we collected these in a nearby freshwater park, whereas the lab-raised, we ordered them. Both of these species tend to reside on the surface like our fungicide, so we thought these were most likely to come in contact in real life.
Okay, now for the second half of our timeline. So in the month of July, once we had the broods of the neonates all within the EPA standards, this is when we actually conducted our toxicity tests. The survived Daphnia were counted and the rest were all disposed of. After we finished conducting our experiment, this is when we actually analyzed our data in RStudio, which is a programming language with a wide database code used for data analysis. Through there, we revised our DRC code, or our dose response curve code package, within it to generate our graphs. And in those graphs, that is where we looked at the LC50 values, or where the concentration at which 50% of our sample died.
Following EPA's guideline, we performed our toxicity tests, and as we said, firstly, we used the active product formulation and required a series of dilution calculations seen in the first image. We utilized a geometric approach, so first we ran a series of range-finding tests, and then later went in and did more acute or gap-filling tests to fill in those spaces and get more accurate results. As seen in the second image, we had around 5 replicants per concentration and around 6 concentrations per trial of Rutendo Gold. With each replicant, we had about 10 neonates, and image 3 shows what an active test looked like, including our control, our various concentrations, and yeah. These were 48-hour tests, and at 24 hours, our mentor would go in and check to make sure everything was all good. And then at 48 hours, Josie and I would utilize a microscope to check the neonates, and we would document the amount of survived neonates and put them on a sheet, and then enter them into Google Sheets, which we then put into our DRC package in RStudio to eventually get our results.
So, we actually found that the wild type and the lab-raised species were affected the same, so that did not support our hypothesis.
So here is our dose response graph produced from our studio, and on the y-axis we had the mortality of Daphnia, and on the x-axis was the following concentrations of mefenoxam, which was in milligrams per liter. In the red is our wild type, or S. micronata, and in the blue we have our Daphnia, which was our lab raised. And overall, our wild type ended up having an LC50 value, which again is the concentration at which 50% of the sample died, of 9 milligrams per liter, whereas for the lab raised, we had an LC50 value of 7 milligrams per liter. While these values varied slightly, we went in and looked at the confidence intervals, which is the range of values that estimates the probability of a true value falling in between these values. And our wild type had an estimated, or had a confidence interval of about 4 to 15, and our lab raised had a confidence interval of 4 to 9. And that's seen in the shaded areas that are kind of overlapping, and this showed that the lethality varied slightly between the two species, with the only difference that the wild type had the ability to tolerate a slightly higher range of concentration than the lab raised, but really nothing statistically significant. As Josie said, our results did not support our hypothesis when we assumed that the fungicides would affect the wild type at a higher rate than they would the lab raised. And again, we assume this due to the EPA's lack of inclusion to all Daphnia species in their standardized types. Though, when looking back at the MSDS sheet for Rutendo Gold, we looked specifically at the type of lab-raised Daphnia they used, which was the Daphnia magna. Initially, we didn't look closely at the number found by the EPA on the MSD sheet because, firstly, they used an EC50 value, which is the concentration at which 50% of the sample is effective, and this tends to be a subjective number and couldn't directly be compared to our LC50 value. And then also, they used, again, the pure substance, which we used the formulated product, and this also led to us being unable to compare them, but we still wanted to investigate this difference. So in the lab, we ran replicants of Rutendo Gold, and the Daphnia magna ended up having an LC50 value of 30 milligrams per liter, which could be directly compared to our data and our suspicion of a significance difference between the other species.
So, in conclusion, once again, our findings revealed that while our species both did demonstrate significant sensitivity to Rutendo Gold, there was no actual drastic difference in their tolerance levels, which does not support our hypothesis. Sorry. But this, as Rutendo said, this did reveal a greater discrepancy. After further investigation into species specifics that was listed on the MSDS sheet for Rutendo Gold, curating preliminary data for the differing lab-raised type, we found that their species differed greatly in the sensitivity to both our lab and our wild type Daphnia. So this demonstrates the complexity of evaluating pesticide toxicity and mortality studies on different species within a genus, and that additional steps need to be taken to ensure that these guidelines are truly applicable and protective to all species across the entire genus to ensure that the EPA is actually consistently deriving accurate results. Okay, so here you can see some of the limitations that were possible during our project. So first, as Rutendo said, we only tested the formulated pesticides, so this means that we use what people actually buy in the store. So we did not test the pure mefenoxam that the EPA does. We also did not explore the full species genus because it's kind of impossible to look at 500 different species in one summer. And then we only conducted our experiment in a controlled lab condition, so it did not go with wanting to play out a more environmentally realistic experiment. But out of all these three, the biggest issue in our project was definitely the first one, because the actual store-bought pesticide, while it does allow for better environmental realism, it does limit our ability to say that the mefenoxam alone is what drove our results in our research, because in the store-bought pesticide, there's other toxic chemicals that could affect the mortality rates of the Daphnia.
In terms of future research, more tests of highly regarded guidelines such as the EPA are vital to upholding the integrity of toxicity testing. Actions like the comparison of various species within a genus create a more accurate database and overall improve all toxicity testing and the protection of our marine and global environment. These are our references. And we just wanted to acknowledge and thank, firstly, our mentor, Melissa Dresnick. As Josie said, this would not have been possible without her, and her patience with us and her ability and love for teaching helped us so much. Next, Mr. DeGroat and Ms. Nuno and all marine chem instructors, you guys made this the best 4 years and truly built up the confidence in us to go on and take on a project like this. Of course, our friends and our families for all the things that come with running a research project and constantly encouraging us and just sticking by our sides. And lastly, but not least, the Marine Chem class of 2025, you guys were the best, and these were such a great 4 years, and truly all of our memories are so invaluable. Thank you so much for your time. And any questions? Yep.
The Daphnia that you guys studied that's local to our area, is that also found across the U.S.?
Usually, again, like we said, there's 500 species, so they tend to be localized, and we wanted to make it more applicable to Washington State, but usually they're found pretty much everywhere.
And then is there a difference in states? What states allow what herbicides, pesticides, fungicides?
There's not very many regulations on what types of pesticides are able to use where, and that's why the EPA is pretty much one of the biggest hurdles in terms of pesticide regulation. And so that's why we wanted to look at their data, because it really is that one stronghold in between pesticides and getting into our environment.
Any other questions?
Any intentions of sharing your information with EPA at all?
Yes, we are going to be sending our research paper to them. I don't know about I don't think they really want to see our PowerPoint, but yeah, we're going to send them our research paper and just kind of get them thinking, because this is actually a really big issue, I think, that they definitely need to consider. Yeah.
If you're going to share with the EPA, you might also consider sharing it with the Washington State Department of Ecology, because they have more authority than the local regulators.
Yes, thank you, Ms. Van Haars. I agree with that. Yes.
Do you look at the pure version of the pesticide versus like the protected one? You know which one had a more toxicity?
So when we actually did the pure chemical, we killed a lot of Daphnia, so I definitely think that one probably has some more toxins in it for sure. So, but that also was the ratio of how much we were actually using, so that was on us for our math errors. But I do think that the methanoxam, the pure, has more toxins in it for sure. Yes.
How does climate change affect Daphnias?
Well, as our water quality is going down, so are the Daphnia in our environment. So I think his question was, how does climate change affect Daphnia? So as our climate change is going down, so is the Daphnia species. So yeah.
And to add to that as well, Daphnia are more an indicator of water health, so they can actually help, hopefully in the future, in looking at water health and combating climate change issues. Any other questions?